But we're gonna dive in. So last time we talked about Twitter, so we're going to go back into that, and we'll pull it up. So let me get that situated, and here we go. So the last time we talked about how Twitter is implemented, and we pretty much just got to the upload post function and how a big thing that we're going to need to worry about is scalability. So the first thing that's going to help with scalability is the fact we use a queue. So this queue here on the left, on the right for you guys, is how we are going to throttle, basically. So when you post, you're not waiting for all, say you're a million followers, you're not going to be waiting for all million followers to be alerted and to have their notifications popped and the post be ready and available in their feed. But instead, yours returned, and it's just an asynchronous thing of, oh yeah, I sent off my request to have my post created. So you get something really simple like that. So we can start diving more into what that looks like on the back end. And let me just put her down. She says hi to everyone. So let's get into what that looks like. So here we have post queue, and we'll go back to diagramming with it eventually. But I want to keep this short, so let's get into it. So now that we've uploaded the post, the user has returned an API endpoint to the person posting the new tweet. It's returned to them, right? It queues a bunch of things, but it doesn't actually wait for those queue items to be popped. So it comes back, and then we can also talk about what this process post function is going to look like. So in an asynchronous thing, like we talked about, maybe a Lambda or a Azure function, you get a notification that it's inserts into the database, and we can talk about more what that schema looks like as we dive into it. But it's a pretty simple relational database where you have a post, and a post is connected to a user. A user is and then there's a followers table, and a follower is connected to a followee user. So both of them are foreign keys to a user ID. So then you get really nice many to many relationships. So super simple structure like that will do the job here. And some other things that we'll get into eventually, probably not today, but we could do another deeper dive another time. I like to keep them high level, just so you're just talking about them. Is you would put load balancers and CDNs and caches in front of all this backend stuff. So it's a post once uploaded, and it's becoming super popular, is going to be cached. So then people like, oh, what the top 1,000, 100,000, whatever the number is, are probably cached. So then you're not re-getting the media, you're not re-getting all the things every time you need to re-get that post. So yeah, there's a couple extra layers in there that are just beyond the back end architecture that we're going to talk about here. And hopefully everyone can hear me okay. So then that goes into the next part. So, I think we talked about enough about upload posts. Let's talk about the get feed. So this endpoint, in Twitter, I was doing some more research because I've actually never used Twitter. So, just very casually a couple times, but I don't use it on a daily basis. So, like we talked about, it's a read-heavy system. Most people are just getting their feeds. And when you say get feeds, there's actually two. There's the following feed, and then the for you feed. And the following feed is strictly posts from people you follow. A for you is an algorithmic approach that combines posts from people you follow, from followed, and recommended by the system. I can spell recommended better than that. Okay, so the following feed's gonna be pretty simple, right? So if we could dive more into this. Let me pull up this thing again. And so we have an upload post function, relational database with a post queue. Let's add another API endpoint. And this is really an endpoint, really. Depending on the architecture, you could also go a microservices approach where each one is its own separate function. But we could. That's for a later date. So this is going to be a get feed endpoint, and to be a little more explicit here, this one's going to take in a pagination token or a cursor. Like current item or something, or maybe current page or whatever you want to do. Pagination can be implemented a couple different ways, but pagination token that allows you to say, I have this set of things. Don't give me the next set. Just give me the ones I want. So a pagination token, and then a feed type. And this is a post to, I don't know, feed. Pagination token, a feed type. So this is follower versus for you. Let's see, what else do you need? You need, that's probably good enough. So what this is then going to do is going to go to a service layer, but really, in the service layer, you're just going to call the database, and you're going to go again, so let's start with just the follower type. So this is going to hit endpoint with a pagination token. Let's do a little numbered list. You always love some numbered lists. So it's going to hit an endpoint with a pagination token, and then it's going to go against the user's ID, which connects to the foreign key of the follows. So we're going to want to index. So when we're talking a database structure here, super simply, over here in the back, let's do another post. This time it's going to be a user table, super simple, basic ID, ID, so an ID, a name, which is a string, an email, so basic things like that, profile picture, blob URL, whatever. Doesn't really matter. But then you're going to have nice things like a follower table. This one is going to have a unique ID as well. But then it's going to have a user ID, which is a foreign key to user. And then it's going to have a followee ID. So we can implement this in a couple different ways, but basically for every follower, so if I follow 4 people, I would have 4 records in the database. Try to get on my camera. 4 records in the database. So I have that many followee IDs, right? So this is another foreign key to user. And let's see if we can make this a little nicer. And then this table is going to be indexed on user ID. So then you can, and indexed on followee ID. So you can really quickly find, do I follow you? And then consequently find all people that follow me, right? So if I'm the followee ID, I want to be able to find that, right? In my list of followers, if that's a functionality. Can you actually view a list of followers? Probably like an Instagram thing. But then this really quickly is going to have a user ID post. So then you can very quickly connect. So you're going to have a lot of joins. So I get a list of follower posts by joining my user to my list of followers, right? It's going to be a one-to-many. I'm only one user. I only need my users' followers. Then I get a list of followers, get all their posts, and then order them by datetime. And take a pagination token, do a skip take, becomes pretty quick, right? And as it's a read-heavy system, we're going to be posting things new, and they should show up really quickly. Now, for scalability reasons, we'll do a read replica, of course. So if I post something, are all my followers able to see immediately? No, probably not. But this is a read-heavy system. I want to always be available for reads. So we'll take a little bit of latency in the writes and a little bit of latency in the read replicas, but I want to read quickly. So have the correct indexes. There you go. Now you can get your feed. Now the algorithmic way is going to be a little more interesting because I want a combination of my follower posts, but then I need to do sort of algorithmic ranking of what's recommended. So in the system, I'm most likely going to have some sort of aggregate where I say, what's the most popular post by metrics? So the metrics are likes, comments, retweets, or views, right? So each post now needs to be connected. Oh, there we go. Now each post probably needs to be connected to a corollary table about post analytics. Where now these are things like view count, big int, things like comments, comment count, and this is going to be just like there's going to be a comments table as well, right? So in that case, maybe post analytics is a view. Maybe we do a post analytics view, which selects how many comments there are. Because then there's also a comments table, and then a post is also going to have like an original post, which is the one you retweet from, right? So most retweeted or whatever. And you start to see how it's so complex and why you need so many moving pieces, right? Because the recommended algorithm, it's like, how do you get the most popular posts on Twitter? Do you do a query every time, or are you doing some sort of, on demand? And in machine learning could definitely be a thing as well, right? Where it's based on the posts and currently how many you're doing, and for you, right? You're trying to target the advertiser. So that starts to get really hard and complex. So we'll leave that to the side for a little bit. Sorry, and I keep going back to this other one. Don't mean to do that. Sorry. This one. So, like we were saying, this one gets really complex really quickly. Howdy, Dread Breadcrumb. Welcome to the stream. Just going over our Twitter system design, talking about the get feed endpoint and how quickly it gets very complex for the for you feed, right? Because it's not just a simple join. It's you have to either gather analytics to be able to make those informed decisions about the post you're showing or anything else. That's where I'm going to leave it today. I just wanted to quickly keep going through and keep having the conversation about what Twitter looks like. Next time we're going to dive into a different system design. Kind of talk high level about something else. We'll see what it looks like next week.